Good day. The objective of this video is to demonstrate a typical user workflow for a metallurgist when using IntelliSense.io's Thickener application on the Brains app platform. The Thickener application has two dashboards of importance to the client users. One is the operator dashboard, which is designed to give the operator frequent updates and information on the real-time performance of the thickener that is being monitored. And the second dashboard is the performance screen, which gives more detailed historical and real-time data pertaining to various metrics that are of importance, for example, to a metallurgist or any engineering side who need to have an understanding of what the current performance of the thickener is, or to go back historically to assess potential excursions or upset conditions or changes in the thickener operation. So as a metallurgist, I would access the Brains app platform and go to the performance screen, because that is the dashboard that is going to give me the most information that is associated with the performance, the current performance of the thickener, and also how the thickener has performed historically in time. And there are three tabs available to the metallurgist, and let's say, for example, the first assessment that the metallurgist would like to do is assess how the feed to the thickener has performed over a certain period of time. So the metallurgist would click on the feed properties, and here you can see the metrics that are associated with that are the percentage solids, mass percentage solids in the feed, and the feed flow rate in volumetric terms, in cubic meters per hour. So for this, the time period that has been assessed and in real time is for the past 12 hours of operation. The metallurgist can change that by clicking on the chronological tab here, which is currently in live, and it shows the operation of the thickener for the past 12 hours. However, if he wanted to do an assessment that goes further back than that, he could change that to days and submit, and the amount of data that has been collected for those two metrics would then change to further back historically to the required time frame that has been set. So for the purposes of this demonstration, I am going to request that we have visibility of the past 12 hours of operation, and that would typically demonstrate a 12-hour operational shift. So again, submitting the data, and you will have the data change and update. So having assessed this, it would seem that there was a reasonably stable operation of the thickener for the past 12 hours, looking at the feed characteristics that are coming into the thickener. Then I would like to see how the actual performance of the thickener occurred. So I click onto the monitor tab, and we are adding additional metrics to the assessment. The first is percentage underflow solids and the bed pressure associated with the solids and the performance of the thickener. So here we can see that there was a slight upset condition during this time period, which was in the early hours of the morning. And again, we can see that at around midnight, there seems to be quite an increase in underflow percent solids, and 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 associated bed pressure, which you would expect. So the metallurgist would want to know why that has happened, and this can be assessed that the likelihood is that it wasn't due to any major changes in the feed characteristics of the thickener, but more likely to do with a control parameter that has been adjusted by an operator during the time that the assessment is taking place. So in order to assess that, we can then click on the control tab, which will give you the two control parameters that are currently being used on this thickener to apply changes to the operation of the thickener, and that is the flocculant dose rate or flow rate, and the underflow flow rate, which is manipulated by increasing or decreasing the variable speed of the underflow pumps. And what we can see here is that initially there was an increase in underflow flow rate, and then the operator decided to reduce the underflow flow, and that more than likely has given this change in the bed pressure and also the percentage solids in underflow. And you can then see that the flow rate was then reduced, and there is a general slowly restabilizing of the thickeners, percentage solids, and the bed pressure. The next objective that the metallurgist may want to do is get an understanding of, without changing any of these control parameters, what the performance of the thickener would be going into the future. So the app allows you 1 hour of prediction capability into the future operation of the thickener, and that is seen as this grayed out area here. So in the drop down menu here, it gives you the current parameters, the set points, just a summary that's easy to reference where we are at the moment, and it gives a predicted performance of the thickener 1 hour into the future. So that offers the metallurgist the opportunity to understand whether there will be any drastic changes to the thickener performance, and give the comfort that the thickener is stable, or if there is an issue that it should be made aware of to the team that potentially there could be an excursion if the current trend is followed by the thickener, and that proactive preventative action can be taken to ensure that there is no instability in the thickener operation 1 hour into the future. The third component or feature of the Metallurgist dashboard for the thickener is that the metallurgist can simulate control variable adjustments and assess what the performance impact would be on the thickener. So, for example, for this thickener, there is the two control variables is underflow flow rate, which is manipulated by means of the variable speed drive output of the underflow pump, as well as the flocculant flow. So current values for these two are 4.59 cubic meters per hour of underflow advanced flow, and the flocculant dose rate is at 1.8. So a metallurgist may want to get an understanding of how a reduction in flocculant would influence the performance of the thickener, and you can then type in the values, so 0.8, and let's say we keep the underflow flow the same, and then simulate, press the simulation button, and then the metallurgist can assess what the impact of that change in flocculant dose rate would have on the thickener performance. And as you can see, that would result in a reduction in underflow percent solids and a reduction in the associated bed pressure to a stabilized performance of the thickener for the next hour into the future, giving you these two metrics that will be sitting at a slightly reduced value from the current performance of the thickener. Once the simulation has been complete, the metallurgist may want to remove those from the equation and basically go back to the existing optimized performance of the thickener. So for the optimized performance of the thickener, here you can see that the flocculant dosage the recommendation is to drop that down to a far reduced flocculant dose rate and to increase the underflow flow rate to give you the best performance or the best stabilized performance of the thickener. So a metallurgist would then take this information and have that discussion with the operators and then collectively come to a consensus as to what the best operating parameters would be that need to be input into the thickener control to get the best performance out of the thickener for the next period of time of measure.